All right, so we're starting 1.4 notes. Quick reminder, you have a vocab quiz tomorrow. Do you remember? I sent the answers on Google Classroom on Friday to that practice sheet. So use that to study. The words you didn't know, you're going to learn today, and you've probably heard of them before. Okay? So let's go ahead and start 1.4 notes. If you're at home, this vocab quiz still applies to you. So make sure you study because you're still going to take the quiz tomorrow. All right, so we've already talked about the first part of this lesson. The lesson is called Angle Measure. So it's all about naming and measuring angles. What is on the side of an angle? What makes an angle? What's it called? Do you remember? Okay, I'll tell you. It's a ray. A ray is a part of the line, but it helps make an angle. So this is a ray right here. When we name rays, we have to start at the end point. So this fill in the blank is end point. So I want to emphasize the symbol. We went over this the first week of school, but this is a ray. So there's an end point and then there's an arrow. Okay, so that means it has a beginning and then it has no end. When you're naming this ray, you have to start at the end point, which is M. Now you can't really see it because it's just a bad picture, but this MP has one arrow on the end. That stands for ray, and then so does MO. So those are all of the ways that you can name this ray. Jay, do you have this note taker? Okay, so as long as you start with M, you could name it MO or MP. Okay, so what we're talking about today is angles. So an angle is formed by two rays. So two rays right here, this is one ray, this is two. Together they form an angle. The rays are the sides of the angle. So the sides, and then we already talked about this. Do you remember what this common endpoint is called? Vertex, yep. So the rays are the sides, and then the common endpoint is the vertex. So if it tells you to name a side of the angle, you have to use two because there's two sides. So you could name it side XY, using X first because it's the endpoint, or side XZ. You always start at the endpoint. Kenya, will you turn that air off? Okay, this is also a review. When naming angles using three letters, the vertex is always in the middle. When naming angles using three letters, the vertex is already in the middle. But remember that there's not just one way to name an angle. There's actually four. So let's name all four ways right here using this angle. So we could use three letters, but the vertex has to be in the middle, which means you have to start on either side. So this could be angle ZXY. Or you can start from this side, angle YXZ. Or you can just use the vertex, which is X, so angle X. Or you can use just the angle, which is angle 3. So those are the three ways. Now, in this picture, there is a plane, and it has an angle, and it's divided into three parts. So I know it only looks like two, but the one one of them is talking about the actual angle. So points Q, M, and N actually lie on the angle. Okay, and then we have two other parts. So the second part is points S and R. Do you see how this is kind of shaded? That is signifying the interior. Interior. Interior is best remembered by inside. So what points are inside that angle? Well, if this is the angle, then inside are S and R. Okay, the third part, anybody guess? If there's an interior, there's an exterior. So P and O lie on the outside or on the exterior of the angle. Notice I didn't name Q, M, and N as interior or exterior. They're not. They're on the angle. So if they're on the angle, I'm not going to list it as interior or exterior. Y'all good? All right, let's go. All right, so here's where we actually start practicing. So for 1 through 4, you're going to use this figure on this side. So it wants you to, first of all, name the vertex of angle 4. So look and find angle 4. Here it is. What's the vertex? U. Okay, name the sides of angle 3. Well, here's angle 3 because it's on the inside of this angle. So now remember, use the endpoint first. So the sides of this angle are X, W. So use your ray symbol, X, W, or X, U, or and X, U. Those are the sides of this angle. What did I start with both times here? Which is that is not by coincidence. Okay, you have to start with the vertex when you're naming the sides. So what's another name for angle 2? Here's angle 2. Now wherever the number is, it's on that, where the number is, like that inside is the angle. So if 2's here, that's not going to, don't think of it as opposite. Wherever the number is, that is your angle. So what's another name for angle 2? Well, what's the vertex of 2? Y. So that's one option. So if this is my angle 2 and y is the vertex, then it's made up of xy and, I'm sorry, not xy, yx and yu. So another name for this could be angle xyu, xyu, or uyx. Okay, what's another name for uxy? So here's u, x to y. So it's talking about this one. Well, I could name it angle 1, or what's the vertex? No. X. One way I knew that without even looking over here. X is in the middle right here. So I knew that was the vertex. Okay? What I want y'all to do, while I take roll of all 7 people, I want you to try to do all of this right here. So start with this one and then go to naming an exterior. All right, so y'all might still be working, but I'm going to start going over these, and then we'll get to wherever you were. Okay? So number 1, name the vertex of each angle. Well, here's 3. So the vertex of 3 was C. There's 3, vertex of C. 8. This was kind of tricky. Well, not really, but you had to pay attention. If here's angle 8, what's the first letter you see when you look at 8? J. But J is not the vertex, it's on the side. The actual vertex is G. Okay, so just be very careful. Name the sides of each angle. You want to know a trick? I don't even have to look at this picture. If this is the angle, then G is the vertex, right? So the sides are GD and GF. Just a little trick. You don't have to do it that way, but the vertex will always go first, GD, and then GF. Now, of course, it also works if you go over here, find DGF, so that's this angle right here. The sides are GF and GD. Works the same way. The sides for 2 were GH and GJ. Okay, number 1. Write another name for each angle. What's a way to name one without looking? Vertex, which is C. So that's one way. Okay, but let's look and let's find the number. BCA, so it's angle 1. Okay, angle 9, I have to look because I don't know anything about it besides 9. So here's 9. So it has a vertex of G, so I could use angle G, or I could use angle FGH, or angle HGF. Okay, 3, you could have used just the vertex, which was D. So E to D to G, that's also angle 5. All right, let's name a point interior to DGH. So here's D to G to H. So anything that is inside right here. What 2 points? E and F. Good. E and F. E and F. All right, let's name a point exterior to HGJ. H to G to J. So there's right here, H to G to J. That's all inside. So what all is outside? F, E, D, A, B, C. Right? Y'all see that? Because this is the only thing that's inside. So any point that's not on this angle is considered outside. So F, E, D, A, B, C. Okay, so next, this is on your vocab quiz tomorrow. Angles are measured in units called, what do we use? Degrees. Okay, so that 360 degrees comes from a whole circle. So in order to measure an angle, we use this little fancy thing that I put on your desk. What's this called? Protractor. Protractor. Okay, let's practice. So, first of all, these 3 are on your quiz tomorrow. Okay, I think you've seen these before. A right angle is equal to 90. An acute angle is less than 90. And an obtuse angle is in between 90 and 180. In between 90 and 180. So, know those 3. Okay, so now our job is to measure and classify both of these angles. Here's the thing. Can't you classify this without measuring it? What is it? It's acute, because it's a cute little angle. You have a hard time remembering acute and obtuse. A cute little, okay? Here's how this works. I like to extend this angle because sometimes it won't line up directly with your protractor, so you can use the edge of it and extend it if you want to see it better. So make sure this dot, or this center of the protractor, is right on your vertex. And then you see this black line right here? Make sure it's lined up with your bottom ray. So now that it's lined up and my circle's on the vertex, you can see that it is 70 or 110 degrees, but we know it's acute, so it can't be 110, so it has to be 70. Okay, so this is a 70-degree angle. Your units are degrees, so don't forget to put your little degree bubble. Okay, what kind of angle is this without even measuring it? Obtuse, because it's greater than 90. So I'm going to extend my angle first. Well, can this angle be 60 degrees? No, so it's 120. Hey, Jay, can you see that white piece of paper? What time do we get out of here? Okay. All right, so now on the bottom, these four. If I were you, I would go ahead and extend every line in this figure. The only angle we know anything about is angle BFC. You see it? BFC. BFC has something the rest of them don't. You see this little square? That automatically means that this is 90 degrees. So that little square signifies a right angle. So the only one I know something about is BFC, and that's because it has the square. So I can automatically say that this is 90 degrees, which classifies as acute, right, or obtuse? Right. You right. Okay, now let's measure the other ones. C, F to D. So we need to measure this angle right here. You can use either side to measure it. You can use ray C or ray FC or FD. As long as it's right on here and flat, then you can measure it. Now just get as close as you can to what degree it is. I got approximately 43. But if I make, okay, let me do that again. I saw some weird places. Okay, so I put my vertex right here, and I put my line right here. And so here's my line. Okay, so I know it has to go, you always go with the bottom one because this is an acute angle. So 40, and it's like right in between. There's 1, 2, and it's in between 2 and 3. So, I mean, I would give or take, like, I'm not going to count you off if you're 1 or 2 points off. But this is 45 right here. So I know I'm not at 45, so I just used approximately 43. Okay? And it's got acute, right, or obtuse. Did I write it on the wrong one? Yes, I did. Sorry. It's acute. Okay, now A to F to D. I'm going to flip mine upside down because here's A to F to D. So I lined it up with the line and the vertex. Now I'm using the bottom number because it's obviously bigger than 90, so it's not 30 degrees. So if this is 150, then I would count over 1, 2, 3. You might say 152, 152, 153. So this measure is 150, approximately 53. I would mark it wrong if you had 2. And then it's obtuse. And actually, on your test, I'll probably give you like 2 to 3 each way. Okay, A, F to B. A to F to B. Now, this one doesn't extend as far, right? I can't even see it. So let's just guesstimate. If I drew a line on top of my protractor without a Sharpie, because that wouldn't come off, and I tried to extend it, I would say that it's, I don't know, 26, 27, yeah. Yeah, okay. Which that's not fair because it didn't extend all the way, so you couldn't really see it. So 20, I'm going to say 7-ish, and that's a cube. All right, next part. Angles that have the same measure are called congruent angles. So if they're the same, they're congruent. Using this little figure, remember how we used dashes last week to signify like if the same line segments were the same? You can do the same thing with these rainbows. So since I call them rainbows, some people call them different things. I call them rainbows. From angle ABC is 65 degrees. Well, since DEF has one rainbow, it's also 65. Now, this line right here, how many degrees is a straight line? 180. So since that's a straight line, and I know that from here to here makes 180 degrees, I know this is 65, so I can find this. 180 minus 65, which is 115. So if this 2 rainbow is 115, this 2 rainbow right here means that's also 115. All right, last page. Remember how we made line, we had bisectors that bisected our line? That means it cut it in half. We have the same thing with angles. So if there's another ray that divides a whole angle into 2 congruent angles, it's called an angle bisector. So bisector always means it cuts it in half. The only difference is that it's used in an angle right here. So Y to W is our bisector, which means this is 80 and this is 80, and together they make how much? 160? Good. Okay, so let's look at this figure right here. Last 3 problems. We can do this. I'm going to use a pencil because they change the measures on us sometimes, and I want to be able to erase it. So in this figure, BA and BC are opposite rays. It's only telling you that so you know it's a line, because opposite rays make a line. So you know that's 180 degrees, A to B to C. Okay? Now, BF bisects CBE. So here's CBE, C to B to E. So that's one whole angle. But BF bisects it, which means angle 3 and angle 4 both can have one rainbow. They're the same. Because it bisects it, it cuts it in half. Okay? So for number 1, EBF, so this little angle 3, is equal to 6x plus 4. And CBF is equal to 7x minus 2. We'll find the measure of angle EBF. This is angle 3. This is angle 4. Find the measure of angle 3. Well, if they're the same, can't I set them equal to each other? Because they're the same. They're equal. So let's set them equal and solve. So 7 minus 6. I got x is equal to, did I get 6? Okay, but we have to plug it back in. Find the measure of angle EBF. Well, it was 6x, but instead of writing x, I'm going to write 6 plus 4. So the measure of angle EBF is equal to 40 degrees. Okay? Not too bad, huh? Number 2. Now, see, it changes a little bit. So I'm going to erase this because it starts over for each problem. They're giving us different numbers. So for number 2, angle 3 is 6y plus 2. And 4 is 8y minus 14. Now remember, the only thing that stands is that BF bisects because it's up here. So it's the direction for all of it. So we're going to do the same thing because we want to solve for y. So let's set those two equal to each other. GW4. So if you subtract 6y Yes. How about I'll finish this one because we have to finish it, and then I'll let you have it. But I don't know. Okay, so here we solved for for y, and we got 8. But we have to plug it back into CBE. So we have to actually find C to B to E, which is both of those. So let's just plug it into 1, and then we'll know 1. Okay, so 8 times 8 is 64 minus 14 is 50, right? 64 minus 14 is 50. So one of these is equal to 50, but they're congruent. So if one's 50 and one's 50, then CBE is how much? 100. All right, last one, then we're going to practice. Here's the thing about number 3. Measure of angle 1 is congruent to angle 2. So I can put 2 rainbows on 1 and 2 rainbows on 2. They're the same. If A, B, E, both of these combined make 100, how much is each one? Together they're 100. Each one is how much? 50, okay? 100 divided by 2. Each one's 50. A, B, D, from A to B to D, which is half of A, B, E, it is equal to 2R plus 5. So in order to solve for R, this was equal to 50. So instead of writing measure of ABD, let's take 2 times R plus 5 and set it equal to 50. So we found R, but now we need to find DBE. Well, D to B to E was just half of it. D to B to E was half of it. So you could plug 50 back in. I mean, not 50. You could plug 20 back in. But don't we already know that both of these separately were 50? So you could just leave it as 50. All right, we're not done with the notes for 1.4, but that's our stopping point today. So let me just remind you what all's due tomorrow. First of all, you have your vocab quiz, which you know all of those words now. So you have your vocab quiz. I posted the answers to the practice on Google Classroom. Didn't I give you 1.3 homework on Friday? What did I assign you? 1 through 20 evens? Odds? No, y'all couldn't do it yet. What did I assign you? Say it again. Okay. Melody, look, is that 1.3? Oh, no, that's 1.4. Okay. 1 to 11? Let me see it. Okay. I think I said 1 through 16. 1 through 16. And then today, 1.4, I want you to do 1 through 16 even. So this was 1 through 16, all on 1.3. Since not everybody's here, I'm not going to check this today because that was Friday's homework. Okay, so I'm going to check all of this tomorrow.